And when you talk, yeah, you probably.
You can just say got it, like you.
I think you just covered screen, first,
Huh?
That's the cream.
Oh,
actually, I think you should first minimize the sidebar and then start recording, otherwise it's gonna record all the screens of people.
okay.
And you can minimize this sidebar thing.
Change the.
Can you can actually hide it, right? You can hide that sidebar.
Yeah,
So you're gonna hide it, right?
right. Hide the view panel.
Yeah, good.
You know, for some reason,
Hide
this
both.
stopped working.
Yeah.
Huh?
Okay, so this is good.
Yeah, it's
Hey, can we
not-
X out
And then-
this sucker out?
Oh, yeah. Get rid of that.
This looks good.
Yeah, you need
Much
to click
better.
on that file first.
Okay.
And can the Zoom people, so Roya, can you hear me?
Yep, we hear you loud and clear.
Oh, sweet. Okay, this is.
Slide looks great.
Okay, fabulous. Okay, so now's a good time to start. Okay, so today it's my pleasure to introduce Chandralekha Singh, who is a distinguished professor of physics in the Department of Physics and Astronomy at the University of Pittsburgh. And she got her undergraduate and master's degree at the Indian Institute of Technology, the IIT at Kharagpur, and her PhD in theoretical condensed matter physics from UC Santa Barbara. She is the founding director of the discipline-based Science Education Research Center at University of Pittsburgh, and she's also you were the president of past, yeah, she was the president of the American Association of Physics Teachers. And she has a number of different awards. And so it's my pleasure to introduce her today and take it away, Chandralekha.
Thank you so much, Mike. And Mike and I have known each other since my graduate school days, so we are old friends. So it's great to visit him also. All right, so I'm going to start out by showing you this picture, which people know as like the most famous Solvay conference, like the sixth one. And one of the things that you should notice in this picture is that there is no diversity here, right? I mean, like everybody in this picture is white, and there is only one woman, that is Marie Curie, right? And so if you look at like what the conferences in physics look like right now, it's only slightly different, but it doesn't look like there is a lot of diversity even now. And so if you think about a classroom, right, what do you think a student who's sitting in the third row, fourth row, fifth row, and looking at all the people in front of them, what are they going to think about, their potential? Will they feel anxious if they don't see anybody in front who looks like them? And I have to say, by the way, that when I was a graduate student in Santa Barbara, I was the only one in a class of 36, only woman. So, that was like, I thought that things would be better in America when I came from India, but it didn't seem like it was that different, right? And so will people feel anxious? Will there be anxiety? And will people worry about their potential in that particular course? And most importantly, what can an instructor do to empower students so that they embrace their struggles and use them as a learning opportunity and create a low anxiety classroom where everybody feels like I can excel here? And struggling is is a stepping stone to learning physics, as opposed to thinking of struggle as something that is actually a sign that I don't belong or I don't have what it takes to excel. Because you can expect that people who are from the minoritized backgrounds, they are the ones who are more likely to question when they struggle, whether they are in the right place, and they start questioning when you don't have role models, when you don't even see people like you around. You're like, oh, maybe I'm not in the right discipline. Maybe I'm struggling because people like me are not supposed to be actually good at this. So these thoughts are likely to come to people. And notice that this kind of thing is what people call fixed mindset. But the problem is that the environment is such and the stereotypes about physics are such that, people say, oh, physics is only for brilliant people. And even a show like Big Bang Theory doesn't do anything to dispel that kind of myth or make people feel like, no, I want to be a physicist if they are not the people who have traditionally been in this particular discipline. So, I mean, I think, overall, like when you start portraying a field as for geniuses, and geniuses anyway associated with men, and you can actually see research studies that show that women try to stay away from those fields, for example, that are actually for geniuses, because they would rather not associate with those kinds of things. And then, what are the kinds of things that physics faculty generally do that make things only worse, not better? Like, for example, like a professor wants to actually, is concerned about a high failure rate in their course. So to encourage students, the professor says, oh, usually 25% of the students fail this class, so they must be careful if their background preparation is weak or something like this. Why do you think this would be bad? First of all, like the person is saying 25% of the students will fail, right? That means that the professor has fixed mindset about students' potential, right? If you have written off 25% of students as failing, even if before you actually did anything to help those students, what do you think that those students are actually going to think about in terms of their own potential? Because you should actually have high expectations of all of your students and tell them that it's really about working hard, working smart, taking advantage of all the resources, right? And I'm going to actually show you some research studies that we have done that have shown huge improvement in closing gaps between minority and majority students in physics. But I think that I hope that everybody understands that this kind of a thing will also create what people call stereotype threats. Not everybody has the same privileges, and people may go to schools with failing infrastructure, the schools that didn't have really best teachers, and yet they may want to be in physics class because physics actually is a fun subject. It's really something that is exciting, and people want to even major in physics, or maybe they want to major in engineering or bioscience, and they still are in physics course because this is something that they need to take. But if you actually say that if their background preparation is weak, then the students who actually had the least resources and least preparation from high school, even though they have the prerequisites, or people from minoritized backgrounds in general, right? They might be like, oh, you have already written me off. And their stereotype, already they're worried about stereotype. Already they're worried about the fact that I don't have role models here. Their threat, will go from like orange to red. They'll be like, okay, I really am not the person who's going to do well in this class. What's the point of even being here? And what I want to say is that cognitive science says that people's working memory, when you process information, when you're trying to solve problems, is actually limited. So while your long-term memory is infinite, you can store as much information as you want over a lifetime. You don't need to purge anything, but your working memory is finite. But it's true that but if some of that working memory, when you're solving problems, is being taken up by the anxiety of the situation, then you have less cognitive resources to actually do processing and problem solving, right? So that is hurting people who are becoming anxious by instructor making these kinds of comments. Here is another one. A student goes, and by the way, we have done so many studies, we have interviewed in my own group, my PhD students and I have interviewed like 70 women in physics courses about their experiences in physics, and about 18 or 19 graduate students. And we hear this all the time. People, when they go to their office hours or something, and it's like, Professor X, I actually really struggle with this problem. Can you help me? Oh, this is trivial. Oh, this is obvious. Oh, this is really easy. And, maybe their intentions are not bad. But what you have to realize is that it's not your intention that matters, but the impact that you are having on the students. So you have to own your impact, right? Because you may say something because you don't think that it's going to have a negative impact, but that's the way people are feeling. A lot of people who have struggled with those problems and who are especially like from minoritized backgrounds, they feel like you've slapped them on their face. They will never come back to your office hours because they felt insulted. Because I struggled with it. I tried half an hour on this problem, and that's why I came to you, and you're saying it's trivial. Maybe people like me don't, are not supposed to be there, or you feel insulted and you'll never go back. So the point is, people need to really actually own their impact and think about putting themselves in student shoes. And I already said that stereotype threat is the fear of confirming the negative stereotype that people have about a particular group, like women in physics or racial ethnic minority students in physics. And this kind of awareness of stereotype that, oh, maybe it's trivial for this person, but not for me, it increases people's stereotype threat. And it puts people in this anxious mode where, their cognitive resources are taken up, they actually feel, demoralized, and their self-efficacy, which is their belief about how good they are at doing physics, actually goes down. And it's like a vicious cycle that gets them down further and further, right? So this is the thing that I'm saying, which is actually a really bad thing, because you made those kinds of ambiguous statements and it puts people in that kind of a situation. So I would actually like to put here a model. Let me actually go back here of equity. So I would say that equity, in my mind, should have three things, like equitable opportunities. Everybody should have access and encouragement and quality educational materials, which is commensurate with students' prior knowledge and skills. Very important for us as physics educators and people who are going to be future physics educators is that you need to have an equitable and inclusive learning environment where people have the right level of guidance and support and mentoring to excel. And when I say mentoring, you should think of yourself as a mentor for your students in your classes too. It's not just for the students who are working with you on your research, right? And everybody in your classes should have equal sense of belonging, regardless of their background. And it's really important that they all are enjoying learning physics, right? And last but not least, outcomes should be equitable. I don't know what's going on with this thing. I thought that was, for some reason, it's changing the thing side. Okay, so equitable outcome means that, like all the different groups who are there, they should actually have similar outcomes. So for example, if you should look at things broken down by how are women doing in this class, how are men doing in this class, because I think that you might see differences that you had never seen before, and then you should be really thinking about, why is it that there are differences. And when I say that, not just, like their scores on physics thing, ask them about their self-efficacy, ask them about whether they feel like they belong in that class or not, because we have found a lot of difference in what men and women say in terms of whether they belong in physics classes or not, whether the instructors are making them feel like, they are not good and things like that. So let me actually show you some data now from my own studies. So this is basically related to self-efficacy that I already said is one's belief about one's capability to succeed in a particular task, course, or subject area. And it can impact students' persistence and engagement in the course. And it can also affect their performance even after you control for prior knowledge of the students, okay? And it can really impact the effectiveness with which people engage with things. Because the other thing is that, when you are engaging with things, as I said, if your cognitive resources are taken up by the anxiety, you're not really putting all of it. The other thing is you may want to also procrastinate on things that you don't think you're going to do well at. So notice that it's doubling hurting people, right? So that's also a bad thing. So let me actually show you some differences that we have found in terms of self-efficacy of men and women in physics courses. So here I'm showing you data from Calculus-Based Introductory Physics 1 and Calculus-Based Introductory Physics 2 at the end of these two courses. The one on the top here is for men and this is for women. The vertical scale shows you like self-efficacy on a scale of 1 through 4. And this is students' grade. And what you see is that at the end of Physics 1, women who have A grade have the same self-efficacy as men who have B grade. And by the end of Physics 2, actually, we don't find any statistically significant difference between the self-efficacy of women with A grade and men with C grade, actually. So it's actually only the self-efficacy gap, which is the gap in what men and women think about how good they are at solving physics problems, has actually increased. This is not an equitable and inclusive outcome, okay? You can see things have gotten worse. And I must say that what you have to also recognize is that it's not just people's grades that matter. It also is important what they think about how good they are at doing physics, because what is going to be their short and long-term outcome and what kinds of things they are actually going to want to do depends also on how good you think you are at those things. Autumn, did you have a question for me?
I have a quick question. Okay, have you done any comparisons of self-efficacy in upper division classes or only in lower division classes?
So in upper level classes, unfortunately, at my university, we have very, very few students. So even though we have done that, we don't have statistically significant, data to be able to tell you. These are classes with thousands of students, so we can actually clearly tell what's going on. But, if you are interested in giving the surveys that we have given, we would be happy to give you the survey, and you can try it here at Berkeley, because I heard from Mike that you have 250 majors at one time, which is like, 10 times higher than what we have. So I think that, you would have some really good, results. All right, so here are some of the things that you hear people say, and I think I'm not going to go over a lot of it, but you can see people are saying, I have such low confidence, self-confidence when I see how other people are so smart, other people understand more than I do. First of all, notice that this is what people are thinking about. And a lot of times it's like pluralistic ignorance. People think, like, I'm the only one who's struggling here. I'm the only one who has this thing. But if you don't do anything about these things, then those things can really hurt the people who are actually thinking this way. Okay. And it's often likely to be people who don't have role models, people who are already stereotyped and who come from these minoritized backgrounds. So let me show you some data, some more data from my own institution. And here on the vertical axis here, I'm showing you the mean GPA. This is the mean STEM GPA for the same students. And here, like, which year are those students in, right? The thing on the top here, and this is for computer science and engineering majors. I'll show you the physical science next. So what you see on the top here are women's grades, who actually completed computer science and engineering major. And the next one is men's grade who completed it. You can see that women on average have a higher GPA than men do who complete the computer science and engineering majors. And same with, if you just look at their STEM GPA. Now, here are the people who actually drop the major, right? And you can see that women, this is women who drop the major, and this is men who drop the major. And you can see that there is a huge difference between men and women's grades who are dropping, right? And women are dropping with significantly higher grade GPA than men are. So this is, again, not a good thing. Why are these people dropping it? Like, first of all, we are making them feel like they don't belong. They develop these worse self-efficacy as time goes on because our, learning environments are not good. Like a lot of times we have interviewed people, and in fact, we've written a lot of qualitative papers too. So if anybody's interested, I'm happy to send you some of our papers on qualitative research where we have done interviews, and you just hear what kinds of things people are saying. And people are like, in the class, I see that the professor is only talking to two men, like who ask all the questions, who answer all the questions, and everybody else is sitting quietly. And in those situations, like people who don't look like those two men are the ones who are likely to feel like, I don't belong. I don't have what it takes to excel. The same kind of thing also happens in office hours, because office hours also are those places where people actually get a cue as to who belongs, who doesn't, who has what it takes to excel and who doesn't, right? And what kind of an impression you do, and whether you actually center the experiences of students who really need your help and people who actually have traditionally been underrepresented, or just those two people who are dominating the scene in the class also, and who come and ask you about, so can you tell me about black holes or neutron star and the research that you're doing in that, or dark energy and dark matter, when the course is about mechanics or E&M, just to impress the professors. It's first not the thing that is relevant for that class, and maybe somebody should say, oh, you should come back at some other time and we'll discuss it, as opposed to using the office hours for this kind of thing, right? But unfortunately, oftentimes this is the kind of thing that goes on in a physics office hour, and it really, is demoralizing for a lot of people who don't look like those people who dominate those situations. But these are quantitative data that you're seeing. And if you look at data from like physical science and math, you see again very similar trends. So women are dropping out with significantly higher grade, right? Here I'm showing you data for percentage of students who drop a discipline, and this is bio, computer science, engineering, math, chemistry, and physics, et cetera, et cetera. And as you can see, physics is the absolute worst. 38% of the students who declare physics major actually drop out. Okay, they just like go into some other discipline. On the other hand, if you look at underrepresented racial and ethnic minority students, what you see is that 65% of those people who declare physics major leave, right? And again, this is shocking, right? But because that means these people actually liked physics, yet they're leaving the discipline because we didn't make them feel like they belong. We didn't make them feel like they had what it takes to excel. They kept questioning, whether this was the right learning environment for them. And then at some point you are so stressed, you're like, I'm out of here. I don't want to have anything to do with it, even if you love the discipline. And so the other thing that I want to say is that that recognition from you, that validation from you as an instructor can go a long way. I don't know if any of you has read this book called The Only Woman in the Room by Eileen Pollock, who was the first woman to major from Yale University in physics in the 70s, And so she now is an English professor at University of Michigan, Ann Arbor. And she wrote how, they had to do undergraduate thesis as a mandatory thing. And she chose to do a theoretical thing. And she said, when I solved that problem, I ran to my advisor's office triumphantly, thinking my advisor would say, Eileen, you did such an awesome job. You should go to grad school. Have you thought about going to grad school? And she said, I knocked on his door. I showed him the thing and he just nodded and went back to whatever else he was doing. And from feeling triumphant, she felt like she was at the bottom of the ocean because she's like, he didn't tell me that I had done a good job. Maybe this was some kind of problem that he gives to every student and it's not really an important thing. And so she said, should I still be asking if I should go to grad school? And then she said, no, if he didn't tell me himself, then, what's the point of asking? And so she basically decided to do her graduate work in English, and now she's an English professor. What is interesting is that when she was writing this book recently, she went back to Yale and that person was still there. So being so much more mature 30 years later, she asked him over breakfast, what did you think about my thesis? And he said, Eileen, not that many people do theoretical work. I still remember it. I must say your work was exceptional. And she said, really? She got teary. She said, really? Do you ever say this to people? Why didn't you tell me then? I would still have been a physicist because I love physics. That was my first love. I still miss not being a physicist. Do you ever say to anybody that they should go to grad school? He said, not really. Grad school is so hard. I don't want to give people the wrong impression. And so the thing is, by not validating or recognizing students, people are actually driving people away. They're reducing their self-efficacy. They're reducing their, sense of belonging. And a lot of people are leaving the discipline saying, I don't belong. I don't want to be here. I don't want to go to grad school or things like that. And so you can see that recognition and validation from you, affirmation, can go a long way as opposed to having those people leave the discipline. And this picture, probably this diagram, this graph you must have seen before, that the number of physics majors has been going up. As if you look at this is the total number of physics majors, but if you look at number of racial ethnic minority students, it's very, very small, right? Here are the percentages. And the thing is, and also, if you look at the percentage of women for the last 15 years or so, it's been constant at 20% at the undergraduate and the graduate levels. Okay, here I'm just showing you, if you look at people who have different disadvantages, like first generation, low income, underrepresented racial ethnic minority, 2 of those disadvantages, 3 of those, what you see is that people's GPA keeps going down, the more disadvantages that they have. This is in their first year, second year, third year. I mean, the trends are like very similar. So, we are not really providing the right kind of support for students who have disadvantages coming in and who are worried about, like whether this is the right environment, and they're not getting the right kind of support. So one of the things that I want to say is that as physics educators, one of the things that we have, or mentors, even in the research lab, one of the things that we have focused on for a long time are these kinds of things. And yes, this is our responsibility to make sure that students develop a good knowledge structure of physics, students become efficient problem solvers and effective problem solvers. One of the things we have not thought of as our responsibility are these things. But if you really think of yourself as a coach for your students, and you should be, whether you're teaching in a classroom or mentoring students one-on-one in research situation, you need to think of strengthening students' offenses and defenses both. And by defenses, I mean, just like if you were teaching chess or tennis, you would focus on both of those things, right? Here, what I mean by defenses are things like making sure that all students have high sense of belonging, high identity as people who can excel in physics. They have growth mindset about students, about their potential in this. By growth mindset, I mean, intelligence is something that you can actually cultivate by working hard, working smart, taking advantage of all the resources, working with other people. And failing is not really failing, but a stepping stone to learning the new thing, right? Because everybody should learn from their failure, because failure is not really failure. That's inevitable. In learning anything, you have to go through things that didn't work out. Right. I gave a colloquium at Brown University, and I was talking to Kostelis, Michael Kostelis, who got Nobel Prize for renormalization group, right? It's not renormalization group, Kostelis phase transition. And he was like, oh, give me some tips, because I'm having difficulty. And, when I said this to him, he's like, yeah, 95% of the thing that I do is I put in trash. It's only 5% that I publish, and I said, Michael, why don't you tell this to your students? They would feel a lot better about, what they are doing, because a lot of times when they're struggling, they are thinking that they are not cut out to be there, or they are, this is just them. Other people just get it. Everything just is obvious to them. When they realize that 95% of the time, what you're doing is not really productive enough to be published, then they will actually feel much better about their own potential, and they'll actually use their struggle as a stepping stone to getting to the next step and the next step, because that's how you are supposed to be, right? But people don't know that unless you actually do something to inculcate that growth mindset. And if you do that, then people will also have high self-efficacy. And notice that with all of these, people will develop greater level of interest, and they will also have a higher level of achievement goal in terms of what they could do with physics. And they will actually learn in an environment where they'll feel safe and supported, right? Not judged. Because one of the things that we are finding is that active learning in an inequitable learning environment actually increases a lot of gaps, between minority and majority students. What I mean by that is that if you just put students to work in groups and you haven't actually set any norms for how they should work, and the point is people from minoritized backgrounds are not getting the opportunity to discuss their ideas, or they're being ignored, or they're not feeling safe to actually convey their, oh, what if I say something and it's wrong? Will these men think that, women can't do physics? If those are the ideas that are going through them, they're not really going to be able to take advantage of that group work completely. That's why one of the things that people recommend is that you should never put like one woman or one racial ethnic minority student with more than one majority student, right? But the point is that also thinking about making sure that everybody belongs and inculcating growth mindset among students is a really important thing. So let me actually show you some of the research studies that have been done in the past. Actually, Carol Dweck is at Stanford University right now, and she did a study a long time ago that has been replicated a lot in the high school context. So this was a study that done basically about how an instructor can actually affect what students want to do and also students' outcome. So here, basically, there were 3 high school math classes that were taught by the same math instructor. And that instructor was told to do slightly different things in the 3 classes, okay? So notice that these initial things are basically their math scores at the beginning of the course. And what you see is that there is no statistically significant difference between those 3 classes that this guy was teaching, okay? But basically, in one class, the instructor was actually praising students for their effort. So every time the instructor would give back their homework or quiz or exam, they'll say, oh, you know, you did really well this time. You must have worked really hard. And whoever didn't do well, you know, I see that you haven't done well, but I know you can do well. It's really about working hard, working smart, taking advantage of all the resources. And I have high expectations of you, and I know that you can meet these expectations. Next time, if you, I want to see that you do better, right? That was the effort praise. The intelligence praise was basically in which that person, when they were giving back the quizzes, homework, and exam, they would say, you are brilliant, you got 10 out of 10. And then when they were giving something to somebody who got 5 out of 10, they wouldn't say you're not brilliant, but effectively that conveyed to those students when every time the person who did well was told, oh, you are brilliant, that they were not, right? What they saw is that at the end, and then the third class, no praise was provided, right? Control praise, nothing was. And you can see clearly here that at the end of the class, what they saw is that people who were praised for effort did significantly better than those who were praised for intelligence, and the middle group was like the control group. And basically, if you read this paper, which is a really good one, they even say what kinds of things students were willing to do in that class. So when the instructor would say, who wants to do really challenging problems? Should we be doing challenging problems today? And the students who were in the effort praise group, they wanted to do challenging because they knew that that was the key to becoming better at things. So they really wanted to. On the other hand, in the intelligence praise group, they really didn't want to actually do those kinds of challenging problems. So we had somebody from Stanford who's now in our psychology department. So he helped us implement a similar kind of thing in our introductory physics courses. So we call it ecological belonging intervention. And if anybody is interested, I can send you our paper, which came out in 2020, so 3 years ago. And so we call it social ecological belonging intervention. And this is a very short activity that you do at the beginning of the course, like it's 25 to 30 minutes. And 3 instructors participated. And these are like huge courses with more than 200 students each. And 6 recitations participated. Recitation means like, you know, all those big classes are divided into these problem solving sessions. And basically the discussion at the beginning focused on the fact that struggling is the only way to learn something new. So you should be proud of struggling and you should pat yourself on the back and you should say, yes, I'm struggling because I'm on my way to learning new things. And so, and the facilitator, the instructors also talked about their own adversity. And they said, you know, when I was in school, I remember I was struggling with the same kind of things, you know, like, and that's how I actually did well. And the idea is to reduce reduce students' anxiety, reduce their procrastination, and increase their enthusiasm for solving challenging problems so that their limited cognitive resources are actually used for problem solving as opposed to anxiety, right? And so, you know, let me show you like exactly what happened in that 25 minutes. So basically, like initially, the instructor will say, you know, the physics department really wants to understand your concerns about being in this course. Here is a sheet of paper. Why don't you write down your concerns about being here? And by the way, these are also first-year students. They are science and engineering students, so they all have to take physics. Students wrote a lot. In 10 minutes, they were asked to stop, right? Then they were shown some testimonials from past students. And these are real testimonials, actually, that were collected. And so those past students who actually were in these courses, who actually said, you know, I remember being really worried about how I'm going to do, but then I realized it was really about working hard, working smart, taking advantage of all the resources. And lo and behold, when I started working with other people, went to instructors' office hours, actually realized that it was really about struggling and failure was not really failure. And it doesn't have to come immediately to you, some problem that you're trying to solve. Lo and behold, in the end, I did really well. You know, I kept working and I did really well. So all of the students, some of the names are male students, some of them are female names, some of them are white names, some of them are non-white names, but everybody's saying it, you know, in their own ways, but the same message. And then after this, students were asked to get together in groups of 5 and discuss with each other, why don't people realize that struggling is actually normal? You know, this is how you learn. And also, why don't people realize that it's actually a good thing? Because this is why you are in college. You know, if you knew everything, then what's the point of even being here, right? And so when the people, and why don't you also discuss what you wrote on that sheet of paper that they were asked to write about, what they were concerned about. And what they realized talking to each other is that everybody sort of was saying the same thing. And notice that it brought down the anxiety of women particularly, because a lot of it, and this was it, at the end of the thing, each group was asked to report, like, can somebody say what this group discussed? And people saw that every group was pretty much saying the same thing. So, which is good, because people then realize, oh, maybe I shouldn't be that concerned, because a lot of people are saying that I'm concerned about being in this physics course, right? Because that was a common theme there. And so if anybody is interested, I can send you the script for this, because we have given it to a lot of people. This is what, initially they were told. So I don't have the time, because I feel like I'm already running out of time, and people have written a lot. That was an example of what the students had written. And then, here are some of the examples of what people have said. This is Allison, who was an electrical engineering major, but I'm not going to actually go through each of these things. But if anybody is interested, I'm happy to send you some scripts. Let me show you the data from our study. And one of the things that we found is that in the social belonging group, there was no difference in the performance of men and women, whereas there was in the control group, right? And in fact, we found similar results by students' race also, as you can see, here, but there were less people here, so it's not as statistically significant as the other one is. But we found similar results. And by the way, the same colleague actually did it in the biology class also, and there they found like that initially there was major gap in the by race, and later there wasn't. So this kind of short activity actually was very helpful. And one of the things that I also want to say is that people who do these kinds of interventions, they have to think about their own mindset about their students' potential also. Because there was a study that was done in Indiana University with like more than 150 STEM faculty, science and engineering faculty in different courses. And they were actually initially, before they were teaching their classes, asked a couple of questions. They had to put it on Likert scale. To be honest, only 30% of the class will really do well in this course, to be honest, those kinds of things. And people who agree with those kinds of things are basically people who have fixed mindset about their students' potential. And those who disagree actually have growth mindset. And what they saw is that the faculty who actually had fixed mindset about their students' potential, those were the ones who had huge gaps between the minority and majority students in their classes. And the ones who actually had growth mindset had very small gaps. Okay, so again, if anybody is interested in that study, I can send you two that came out in Science Advances in 2020. But notice that your mindset as an instructor makes a big difference. And in fact, it's really nice. There is this faculty, Roland Kawakami at Ohio State University. He said, after he heard my talk, he said, I first had to think about my own potential, my own mindset about my students' potential. And he said, it changed my life. He literally says, it changed my life because now I actually think about students in a totally different way. And he's like, now my relationship with my students is totally different. And when I do this beginning intervention for 25 minutes, the relationship of students with each other is very different. And that is exactly the point. That's why we call it ecological, because your relationship with your students and students' relationship with each other changes when you really think about the fact that you have the power to really empower all of the students and make them work hard, work smart, and take advantage of all of these things. And so one of the things that I wanted to say is that the same kind of thing also applies when you are actually doing mentoring of your students. And again, you should be very explicit and make it clear to students that research doesn't go in a straight line, like things, you'll have setbacks, but everything that you do, even if it doesn't work out, you learn from all of those experiences, and everything actually adds to, what you will do next and what you will do next. So do not, and keep telling your students that, this is how research goes, because again, otherwise, some people are going to be very discouraged and they'll think that, and if you don't explicitly say, no, you're doing good, you're actually making progress, this is how it's supposed to be. A lot of people who are from minoritized background are the ones who are more likely to think I'm not doing well. I must not be doing well because things haven't worked out the way that I would have expected, because, they're thinking about things that, the timeline for something to be working out in one way. And you are the one who knows how it should be working out, and the fact that you are making progress over a longer period of time, that's the thing that is most important, right? So again, you have the power to empower your students. And I think that it's really important that you think about these kinds of issues when you're actually trying to teach or mentor your students. So at this point, I'll take any questions from you. Thank you. Please.
Yeah, I have one question. So there was a slide you were showing the dropout rate of different subjects. Can you go back to that slide?
Please. Yeah, go ahead. And the question that you had.
Yeah, so in that slide, it was also showing two things. One is that
Mhm,
the physics subject had the highest drop rate.
mhm,
So within all students versus minority students, the minority the drop rate even increased.
mhm.
But on the other hand, if you look at another side of the extreme, you look at also, another subject that is CS, computer science, the drop rate even lower for minority student versus all students. So I'm curious, like, do you have any observation? What is happening with
Okay,
CS field?
Right.
They do. So.
Yeah.
Okay,
So well.
so notice, okay, yeah, so computer science actually is in the School of Computing and Information, and they have like much more stringent requirement for when you actually can declare as a computer science major. So in other words, like you have to have taken like 4 courses in, computer architecture, this programming, this, data structure or whatever else, like they require 4 courses before you can even declare a major. So in other words, and by the way, the percentage that I'm showing you here actually doesn't include those people who actually dropped out even before declaring a major, right? So for example, like I must say even physics majors mostly declare their major at the beginning of sophomore year, okay? And I know for a fact that a lot of people, even at the end of introductory physics, they're like, I'm out of here. Initially I thought I would major in physics, but now I don't want to anymore. I've had such bad experiences in introductory physics, I don't want to have anything to do with it. So I'm just saying that computer science is lower because of the fact that they have higher stringent requirements. And I cannot exactly tell you like why this is lower here for the underrepresented minority students compared to that, but the overall rate being lower than everybody else is because of the more stringent requirements. Then you can actually even declare a major.
I'm sorry, was this your data or is it from another?
Okay, so these are all from University of Pittsburgh, actually.
So this is your data.
Yeah.
From university.
I would be surprised if large research universities are very different. In fact, I'm part of this. In fact, I'm going there, next week because I have a conference at University of Michigan to go to. And this particular group of 10 different large universities, but they're all public institutions. It's called Seismic Sloan Equity and Inclusion in Introductory Physics courses, it's called, but actually we look at all STEM courses. And so the Seismic collaboration is 10 different universities. There are 3 UC schools that are part of this collaboration: UC Santa Barbara, UC Irvine, and UC Davis. And we actually compare data with each other, and you will be amazed at how similar all the results are. So basically our goal is to actually, do these kinds of data analysis, across different institutions and see what is similar and what is different. It's true that UC schools have slightly larger percentage of underrepresented minority students. But even then, if you look at the overall trends at these institutions, they're bad all the way across, at all of these institutions. So that's the huge advantage that we have by having this 10 large research universities collaborating on this thing. And this collaboration has already gone on for 5 years. So this is like our 5th anniversary of this conference is that 5th anniversary conference next week. Please.
Is there any so I specifically looking at undergrad, there's a disparity between students who come from high schools with lack of resources compared to students who come from high schools with a lot of resources. And I think that a lot of the time I get the sense that students who are like minorities come from high schools that lack resources. That's why going to college is a pretty hard transition compared to students who go to high schools with lots of resources. But is there studies specifically, I want to say like on students who go to high schools with lots of resources and are probably in a high economic bracket, but are still racial or gender minorities, and then they still also perform lower than their like white or male counterparts in college?
You know, I think that that would be a really good study to do. But I think that the fact that the percentage of underrepresented minorities is already so low, you know, and also figuring out like, you know, like how to disaggregate data like that, you know, like that would be a difficult thing. But did you see that I actually showed you, yeah, this particular thing, right? So if you look at this particular thing, do you see that, you know, if you are first generation low income and underrepresented minority, you have triple disadvantage, and, you know, like, actually it's really affecting, because this means that these universities are not really providing support. And by the way, this data has been replicated at almost all the 10 universities that I'm talking about. So UC Davis has similar kind of thing, UC Santa Barbara, and so UC Irvine, they find similar kinds of trends, right? Similarly, like if you look at low income and URM, okay, so this is this, right? Just URM, like, you know, that, so in a way, like what you're saying is sort of is being reflected here. Do you see that, like, in a way? Yeah, sure. Please.
We mentioned you had some scripts, but I'd love to see those, but.
Absolutely.
Earlier on, mentioned, you know, you're talking, if you know, something about like asking about self-efficacy. Making sure that's part of the conversation. I was wondering if you had suggestions of a way to do that that wouldn't take, number one, how in your study did you ask about a student's self-efficacy? And how can you do that without triggering self-consciousness about that?
Okay, so first of all, like, you know, like all those surveys, we give it at our university. We have been doing this since 2015. So since 2015, we are giving these surveys now as a rule in all of our courses. So at the beginning of the course and at the end of the course. So this is what we call departmental assessment, you know, like, so every faculty is like giving it at the beginning and at the end of the course, right? And so, and notice that we are not really asking people to write their name on that thing. No, their name needs to be written, sorry. Their name needs to be written, people start to, but they don't write their gender or anything. That stuff comes from the office of the provost. So all this stuff here, you know, that kind of thing now, provost office provides data on, and in fact, all the 10 universities that are involved in this kind of research, they are all provided through the provost office. So you don't really need to ask for those things. I mean, if you are thinking that those things will trigger stereotype threats, because sometimes people say that, you know, asking for gender information or race information at the beginning of a test can itself make people, you know, remember those things, and it can increase your stereotype threat, because people have seen differences based upon whether they actually were asked to write those things or not. But that's not what they are being asked for here. And the self-efficacy questions are questions like, you know, I feel like I'm, you know, really good at doing physics problem solving on a scale of 1 through 5. You know, 1 means strongly disagree, and 5 means strongly agree. Where would you rank yourself? That's those sorts of questions. And there'll be like several questions that you average over.
That makes sense. Because I was thinking, in a one-on-one conversation, it's hard to ask those later questions about self-efficacy without maybe some of the stuff, like if you're sitting with a student, say, how well do you feel like you can solve the problem?
Yeah, no, this is being given to everybody. And the point is, like, you know, if you all are interested in, you know, giving it here, like, I would be happy to send you what we have given since 2015. And we are now giving it in all of the courses, even upper level. The only thing is that the statistics, even over that period of time, since they're only 20% women, and we have only 20 to 25 majors each year, very few actually. So, and so that means we have so, you know, such a small number of women that it's not very statistical. Please.
You mentioned when making groups that it's a bad idea to have one underrepresented student with like more than two like majority students. If you, I mean, part of the problem lies that there's so few underrepresented students to begin with. So how do you recommend making groups then to work together on a problem? Like, is it it feels very awkward to say, okay, all of you guys go over here, like that doesn't seem right. So how would you recommend people do that?
So, so this is the thing that has been researched a lot, actually. So one of the things I would say, first of all, is that if a student really wants to be with somebody, you should let them be, right? I mean, you should not like override a student's opinion. So if they feel like they're friends with some people and they want to really do it, let them do it. But in general, if you are the person who's actually deciding on it, even if there are very few underrepresented minority students or women in that class, then you should actually, and it's okay to make only a few groups with those people being majority, than like putting them in like each group and making sure that there is only one. Because otherwise it's going to be very detrimental. There are video data on these kinds of things, and they're very shocking. When you look at like those videos of how the interactions are going, it is really shocking. And what is also interesting is that, like in this regard, I have actually not just done research at my own institution, which is obviously a very large research, we have 36,000 students there. But we also did some actually individual interviews with women at a very small college with 2,000 students, right? And at that college, like very expensive college also, what we found in those interviews, like, few interviews, but like even of the order of 10 will give you a good idea for, how things are going for these women, right? These are all physics majors, women who are physics majors. I wanted to understand how are the experiences of physics majors that we have, because we have done 70 women from our own school over these years, so we have done a lot of interviews. As opposed to like those people, what I found is that they were actually saying a lot better things, that small school, the women from those, about their instructors, than people at my institution were saying about the instructors at Pitt, for example. They would be like, they didn't really care as much as, those people said they did. But with regard to like the interactions with peers, very similar. Those women were as negative, they were talking about how their interactions with their male peers were not good, and instructors didn't really understand all those issues, like they didn't understand that they were really marginalizing them in many ways, how the interactions were going. So I think that there is something to be done, like instructors should actually try to create an environment where people are not, one group is not dominating over other students, and making a group in which there's only one minority student, it's even more likely to happen. Does that make sense?
Absolutely.
Yeah. And notice that it's not just a problem at the large research units, it's happening even in smaller places.
I'm curious if you could give just your, you don't have like a summary, like as an instructor, what are the, what would you prioritize? It's just like is there like some fast takeaway, okay. Like it sounds like this 25-minute thing is a good thing.
Yeah, that is definitely a very good thing to do. And Mike, I was asked by the Nature Physics editor to write a review article on this particular topic of how to make the classrooms equitable and inclusive. And I think that he was telling me that it'll come out in the December issue. So there we have a bulleted list of what the departments could do and what the faculty could do. So maybe like, I can send you a preprint of what we have right now. It's still undergoing peer review process. I mean, the second round of it. But, I think that there we have like a recommendation for each group. And I think maybe that's what you're looking for.
Yeah.
Right?
Yeah, the one page bullet.
Yeah. And that's the kind of thing. So I think that we have a whole bunch.
But this 25-minute.
Yeah, 25-minute thing is basically, at the beginning, but that's like the first thing that you need to do. I mean, you shouldn't think of that as the only thing, but notice that also makes you think about what are the kinds of things you need to do and how your own mindset is actually making a difference. Actually, you see what I'm saying? And you know, as I said, I can send to Mike that Roland Kawakami's video too, and how he says that he's totally sold on doing that kind of intervention at the beginning, because he's like, it really made me think about what do I think about students' potential. And it really changed my life, he says, you know, like my relationship with my students has never been better. And their own relationship with each other is different because of the way that I framed the whole class at the beginning of the term. So I'll send you that video.
Okay, yeah, I'm curious.
Yeah.
Maybe we could ask the Zoom, hello Zoom audience, any questions or comments from Zoom audience?
I
It's been quiet, so I don't think there's anything from the Zoom.
Okay, thank you, Roya. Okay, well then, if there's no more questions, let's thank.
well, thank you. I hope that, you know, like you guys do something about these issues, right? That's the important thing. So I feel like, you know, giving a talk is only helpful if people will really think about these things seriously and do something about it.
That's why I need that bullet of this.
Yeah, and that's why I will give you, I'll send you the preprint.
Thanks.
Yeah. Thanks, everybody.
Thank you so much.
Thank you.